Have you ever wondered how chemists deal with tiny particles like atoms and molecules? These particles are so small, you can't even see them under a microscope. So how do we measure something we can't even see? That's where the mole comes in. Imagine you're buying mangoes. You wouldn't buy just one or two, right? You'd probably buy a whole dozen. In chemistry, we use the mole like a dozen for atoms and molecules. It's a big, convenient unit for measuring these tiny particles. Just like a dozen mangoes is equal to 12 mangoes, 1 mole of anything is equal to a specific number of particles. This number is huge. It's called Avogadro's number. A mole helps us to think about and work with these extremely small particles. The mole concept is a fundamental idea in chemistry. It helps us understand how much of a substance we have at the atomic or molecular level. It's like a secret code that unlocks the world of chemical reactions. Remember that huge number we talked about? It's called Avogadro's number, named after the scientist Amedeo Avogadro. This number is 6.022 times 10 to the 23rd power. That's a 6 with 23 zeros after it. It's a mind-bogglingly large number. Think of it this way. If you had Avogadro's number of rupees, you could give everyone on Earth 1,000,000 rupees, and still have plenty left over. That's how big this number is. Avogadro's number is like a special measuring stick for the microscopic world. So, 1 mole of anything contains Avogadro's number of particles. 1 mole of water molecules is 6.022 times 10 to the 23rd water molecules. 1 mole of sodium atoms is 6.022 times 10 to the 23rd sodium atoms. It's that simple. Now let's see how we use moles in chemistry. Imagine you're baking a cake. You follow a recipe that tells you how much of each ingredient to use, right? Chemical reactions are similar. They have recipes called chemical equations. These equations use moles to tell us how much of each reactant we need to make a certain amount of product. It's like a recipe book for chemists. For example, to make water we need 2 moles of hydrogen for every 1 mole of oxygen. By understanding moles, we can calculate exactly how much of each reactant we need, ensuring we don't waste any chemicals and get the desired amount of product. Moles are essential for accurate measurements in chemistry experiments. The mole concept isn't just for chemists in labs, it has real-world applications too. For instance, doctors use the mole concept to measure the concentration of glucose in our blood. This helps them diagnose and manage diabetes. Environmental scientists use moles to measure pollutants in the air and water, helping us understand and address pollution. Even in industries like pharmaceuticals and agriculture, the mole concept plays a crucial role in research, development, and production. So next time you hear the word mole, remember, it's not just a furry creature. It's a fundamental concept in chemistry that helps us understand and interact with the world around us in countless ways.